Lesson 4-8, Example 3. Our objective is learning to add and subtract fractions with like denominators. And here we have an algebraic expression, 5/9 minus x. Well, let's say that x is equal to 2/9. So, if I wanted to evaluate this expression for x equaling 2/9, I would just take it 2/9 and put that in for x. So I could rewrite this problem, 5/9 minus 2/9. Well, I have like denominators. These are both the same size things, and I have 5 of those pieces here, and I have 2 of those pieces here. So I can just say that if I have 5 of these ninths, I'm taking away 2 of those ninths, I'm left with 3 of those ninths. 5 minus 2 is 3, and the 9, that denominator, because it's what these things are, stays the same. And 3/9 can be simplified down to 1/3, and whenever I can simplify, I like to do that. So I always try to do that. Let's see what I do with a different problem. Let's say x plus 2 4/9. And again, we'll keep x equaling 2/9. So in this case, I'm going to put 2/9 in for x again. So 2/9 plus 2 4/9. I want to focus on my fractions here, so I'm going to ignore this whole number for the moment and think 2/9 plus 4/9. Well, I have like denominators, they're the same size things, so I have 2/9 plus 4/9, that's going to be 6/9. My whole stays the same, so I end up with 2 6/9. Ooh, I can reduce that down to 2, and 3 is a factor of both of those. So I end up with 2 2/3. Let's look at one more. Let's have x plus 8/9. Again, where x is equal to 2/9. So 2/9 is going to go in for x, and I end up with 2/9 plus 8/9. So I want to know how many ninths do I have overall. Well, I have 2 and 8, so I have 10/9 overall. Whenever I have an improper fraction, so I'm left with an improper fraction here, I'm going to simplify that to a mixed number. So 9/9 is a whole, so I can take one whole out of this. I could think of that as a whole, and I'm left with 1 1/9. So I could think of taking out 9/9 plus 1/9, and this 9/9 is just like saying one whole. So 1 1/9 is my final solution there.